friends. Welcome to Enlightning. It's been a couple months since we've done a show, and I'm so excited to be back. And I'm excited to have Peter here. Peter, thank you for being our guest today. Please introduce yourself and tell us what you're going to teach about.
Hey everyone, thanks. I'm happy to be here. I'm from Budapest. A little bit about my personal background. I have a family. I have 4 kids and 2 dogs, so I'm quite busy after
Yeah.
hours as well. I love to play hockey. I learned to play a few years ago, and I'm doing it since. Um, and yeah, about my professional background, a little bit. I'm a software engineer, but also a product owner.
Mm-hmm.
If we can say that, I love to wear multiple hats. I also love to be a DevOps engineer or an infrastructure guy if I have to be. And I've been an engineering manager
Cool.
for a year. So really, I love to do multiple different things. Uh, Sometimes even multiple of these in a single day. Uh,
That's so cool. One thing that fascinates me about folks like you. So I went to like a coding boot camp in 2019 and only got into tech in the fall of 2019 is when I first learned what Kubernetes even is. So folks like you who have been doing it a long time, like we're coming up on the 10-year anniversary of Kubernetes. So do you remember when Kubernetes like first started coming around and could you foresee how it was about to change the way the world works?
yeah,
What were your feelings?
actually, I remember. Yeah, we've been working at Ustream with some of my friends who I still work with. Ustream was a small company similar to StreamYard actually, that allowed people to live stream whatever they had in front of their phones. And we did a few things there. A large scale streaming service with HTTP services as well, and we did experiment with service discovery tools like Consul, for example, and such. And there was a big debate when Kubernetes came up on the stage, and it seemed pretty opinionated, and
Uh-huh.
we've been arguing back and forth whether this is a good thing or not. A lot of
Fascinating.
things we have to I don't know, consider. And we were running all on VMs. So this thing came like a storm with containerization and Kubernetes, and we didn't know what will be the future of
Yeah.
these things. But yeah, and then just a few months or a year later, we were all in on Kubernetes, and started to build services using Kubernetes everywhere.
That's super cool. So, does anyone else in the chat remember the beginning of Kubernetes? Hello, Nikos. Thank you for being here. I'd like to hear your stories, but I'm going to start moving on behind the light board. I'm going to share some links. We're talking about the logging operator today. We're actually, so for Enlightening, I'm starting a whole series where I hope to cover all of the CNCF observability related tools. In the past, like more than a year ago now, I did an episode on OpenTelemetry. So I know a little bit, and I did just a general observability episode, even way back at the beginning. But I, what I would, um, uh, excuse me, someone. Okay, excuse me. Sorry, I just got distracted because someone I don't know just logged into our StreamYard studio. So, hello. I'm gonna just ban the user. I'm sorry. I just totally lost my train of thought. So hello again. So what I what I was saying is I don't know very much about observability at all. So for better or worse, Peter, I'm going to need you to explain more to us than maybe you would had you come later in the season. So the good thing is that you get to tell me your opinions up top, so they'll anchor how I look at everything coming after this. But the bad news is you might have to explain from the beginning a little more than other folks need to. So I've shared some links in the chat. And while I move on over, we have another. Njit says Kubernetes started by Google as a work project. Yeah. Cool. So while I move behind the lightboard, Peter, will you tell me more about your career and tell me about how you came to be one of the maintainers of the logging operator?
Okay, sure. So back, I already mentioned Ustream. There was where we initially started to use Kubernetes, and it was very soon when we faced the problem of managing logs. And then we started to put together a solution and architecture that works well in Kubernetes, collects logs from the different pods, and forwards them in a reliable way to Elasticsearch. That's even today the most common use case that we see people are doing as well. So it had a lot of small tweaks that we had to make, and it was very manual. And when we later left Ustream, which was acquired by IBM back at those days, some of my friends started a startup called Banzai Cloud, where not just logging, but it was more broadly about providing tools on top of Kubernetes, and also to manage Kubernetes clusters, actually, for developer teams or enterprises, to make their lives easier. So managing clusters, managing Istio on top of these, connecting these clusters, and multi-cluster Istio, and service discovery, and also we had an operator, Kafka operator, which was really cool, and was very different in how it was targeting that problem. But anyways, we also had the logging operator as the idea. So we wanted to, we had an initial architecture that consisted of FluentBit and FluentD. We can talk about why and how that works, and we wanted to automate this, because that was the time when the operator movement started by CoreOS, and they documented or made their ideas public, and the etcd operator and the Prometheus operator came alive. So we also wanted to have an operator that solves this problem for us. And I wasn't there when the initial version came out, but it was still very focusing on this problem, just FluentBit, FluentD. And then we reiterated it and came up with these Kubernetes native Kubernetes APIs that introduced a new concept called a flow and an output, so that you can manage certain flows that fulfill a requirement that certain developer teams or certain users might have, which could be different depending on what those users need.
Cool. So I'm kind of getting a preview a little bit in your description, but what I would like to understand is what was the problem that existed in Kubernetes, or I guess in the world that caused logging operator to be created?
Yep. The primary problem is that the configuration of collecting these logs was a bit messy, and the root cause of the problem is that although Kubernetes is opinionated in a lot of things, it is really unopinionated about how you want to collect and manage your logs. So what Kubernetes does is that it provides you a nice interface you can interact with, which is kubectl logs, an API that can stream logs for you. It's not a reliable way to collect and ship your logs to a persistent store or to a nice place where you can actually search and do other things with it. So
it's not reliable, and what else?
uh, it's just a one-off command, a tool that is just a nice user experience, but otherwise not a way to collect and forward your logs to remote destinations.
Okay. So it's good for viewing logs, but it's not good for storing collecting forward logs.
Yeah.
Okay, so Kubernetes doesn't have a native way to do this.
But the good thing about kubectl logs is that it's part of the Kubernetes API, so it's covered with Airbag. So you can define permissions, who can see logs, who can't. That's great, but the way Kubernetes actually stores the logs is that it just leaves that up to the container runtime. So, which is typically the container runtime just writes out logs to disk. That's the only thing it typically does if you don't do anything else with it. So
delegates logs to the
yeah,
container runtime.
It doesn't want to solve that. It just delegates it. And kubectl logs under the hood is actually a way that the Kubernetes API provides you to connect with the kubelet, and the kubelet can actually understand where those logs are, and it can stream it right from there.
So for viewing only, is that correct?
Yes.
Okay. So basically, Kubernetes is counting on you to come up with some other logging solution. It's not trying to do it for you.
Yeah, and that totally makes sense. So this is the same idea why they don't want to solve the secrets problem, why they don't want to solve other things that sometimes the communities was mad about, but totally makes sense because they had to focus their efforts on the problems that this orchestration system has to solve. So this is up to us how we do this, and so container runtime is running on a node and managing all the pods that is assigned to that node, so or scheduled to that node. So if you are running multiple or multiple teams, multiple users are running workloads, they might end up running those different workloads on the same node, and the logs for these different pods, workloads, teams will end up in the same folder.
Okay. Yeah.
And well, it's not necessarily have to be this way. So if there's an application that has a library or a capability to send logs directly to some remote endpoint, then it
Mm-hmm.
can of course do that. But it's typically not how applications work. They stream logs out to standard error, and
Mm-hmm.
this is the safest thing to do, because otherwise, if they send their logs to some remote destination, then they have to care about what if that destination fails. Should I retry?
Yeah.
What should I do? Should I block? Because
Yeah.
logs are important. So audit logs, for example, I can't lose an audit log. Then I block the execution and I return a denial to the request. So what do you do with these? And
Yeah.
reliable ways. So this is why. Well, I just write it out to standard out. That should be
Decouple the
yeah.
the source from the destination. That makes
This
a lot
is
of sense. Yeah.
yeah. Sorry. So this is
Uh,
different, a little bit different with traces and metrics as well, because if we are talking about telemetry, and right now we are mostly just talking about logs because that was the initial concern. But you also mentioned OpenTelemetry, which is about telemetry signals in general. There are different ways for each of these different signals how they typically emit their logs or traces. Traces are typically emitted to remote endpoints. Metrics are typically scraped through an
uh-huh.
HTTP endpoint provided by the application. So it's very different how these work, but logs are typically written to either files or standard out.
So logging operator only deals with logs, not metrics or traces, correct?
Well, it traditionally it was concerned with logs only, but we will get to the
We'll get
point.
there.
Yeah, so telemetry controller, which I asked you to share the links with the audience,
Yeah.
is a new sub project that introduces open telemetry for the collection part, um,
Mm-hmm.
and and that in we are going in that direction where we are not just dealing with logs, but we want to provide the same multi-tenant routing mechanism for all the different signals. We will get to that later.
So what I would like right now is to get a nice succinct definition for what logging operator is onto the board. Does that sound good? Is it the logging operator? Right?
You mean that there's only one logging operator?
Yeah, is it called logging operator or the logging operator?
Um, it's logging operator
Okay,
without.
cool.
I think there is another one with the same name or similar name, uh, and with the telemetry controller, it's now more than just logs.
Yeah.
Actually. So yeah, but what logging operator is at the moment
Mhm.
is really what is in the title is a multi-tenant log collection solution for Kubernetes.
Multi-tenant.
And of course, as I said, we will be able to say that it is a multi-tenant telemetry data collection system, but this is where it is headed at the moment. Yeah.
Okay. It's a logging collection system.
Um, log management solution.
Okay.
Let's call it that way.
Log management solution for Kubernetes. And then I'm going to do this, put a star here, soon to expand to telemetry.
Yes.
No, include.
Yeah.
And by telemetry, what do we mean? Do we mean, does that mean like logs, metrics, and traces?
Yeah, and profiles.
And profiles.
Yeah, later. Yeah, so everything, because we are concerned about so what when I say management, I mean routing, collection, routing, and isolation as well, and some transformation. So all these things are important because these are in most cases these are all required to get logs from A to B.
So those of you in the chat, I would like to hear what you're using for logs now and how you're solving this problem of like different teams' logs all end up in one spot. Different people need different things from what you're getting.
Spots.
Different spots. Okay. But maybe. How are you managing how different personas and different teams are able to access just the logs they need and not have to sift through all the extra data? How are you solving that problem right now? And then from you, Peter, management, you said, can actually include a lot of verbs. So will you repeat just the verbs, like collecting, processing, maybe forwarding? Are those correct?
Collecting, routing.
Cool. What else?
Transformation.
Transformation.
And if we can call this forwarding, so understanding different destinations, and so that you don't have to bother with adding another component just because you need to send your logs somewhere else. So it's forwarding, probably. Understanding, destinations, protocols, yes.
Cool. And we have a space point.
Sorry, one more thing, isolation. So isolation as well, yeah.
I'm gonna destination/protocols. Isolation. Good. Nice. Space boy. The logging operator for 5 years to Graylog. I'm unfamiliar with Graylog. And Space boy is a fan of Graylog, it sounds like. So that's cool. Thanks for replying. And so so I'm starting to get a picture of the problem, and I understand that logging operator is the solution, but I don't really understand what's going on under the hood to make it happen. Do you want to get into that part of it? Yeah. Or would you prefer to talk more about use cases, like examples might be a good next step?
No. I think we can get to how the basics work when so getting back to the point where we initially had to send logs from a Kubernetes cluster to Elasticsearch. Some logs, not necessarily all. So even if you are a single tenant, and by routing we can also mean filtering, but the point is that you have a lot of different workloads running, and you might have some reasons because of compliance or just developer efficiency or whatever. So you need to um, have logs for some reason in a remote destination. For example, because Elasticsearch provides a nice way to build dashboards and graphs and so on, or Loki and Grafana and whatever. So you want to enable your developer teams, or you need to archive all the logs to some storage S3, for example, and and if you just have a single thing to be concerned about, you might even not want to send all the logs to a destination, because you don't want to send the Kubernetes components logs, all the I don't know, the kubelet logs or whatever. You just need to send logs from a single namespace to a destination. So in that case, even in that case, you need something to collect those logs and forward them. The easiest thing, so how it starts is typically you want a daemon set to do this. You want a daemon set that runs on all the nodes, mounts the host folder where all these logs are written by the kubelet, and start to tail these logs and forward them to somewhere. There are a few problems with this already.
So at this point, are you still just using Kubernetes log collection, or when you add this daemon set, are you adding a different piece of software?
With this daemon set, you already have to put your vote to some solution. For example, FluentBit is the typical solution for this. FluentBit is the most widely used solution, even in AWS. It's the default in GKE log collection and a lot of places. So we can say that FluentBit is the tool for this job. At least it was until now.
Exciting. Yeah. We're doing a FluentBit episode tomorrow, actually. So
yeah, I mean, I'm referring to OpenTelemetry Collector. That is the new kid on the block, or not that new already, but that's where we are headed with the telemetry controller.
Cool.
So yeah, so FluentBit can tail files, and well, you have to decide if you don't want to send everything. Then you have to decide somehow what to send and where. So there's a few things here. You need some filtering and routing. This was what I meant by routing. Actually, you need to make a decision based on some information in the logs, or in the metadata that can be attached to the logs. And here we already have a problem to solve that FluentBit solves, actually. And I think most of the log collectors solves that. When they start to read these files, they can be instructed to ask the Kubernetes API server or kubelet about some more metadata about these files, because the only metadata that you have is the file name when you start reading these files. So you don't know exactly all the details. You might need to know, for example, pod labels and well, pod labels is the most important one, or are the most important one.
Labels, you said?
Yeah, labels. Yeah, Kubernetes pod labels.
Okay. So you need to make filtering. So you want to send logs to a remote destination. It seems straightforward, but now you need to add a daemon set. And when you do that, you're choosing a technology. You also are making decisions about filtering. So which logs you want to go where and which metadata to use.
Yeah, can be correct filtering to routing so that we are consistent with what we wrote.
Absolutely.
Sorry, I was the one who.
No, I love that your attention to detail.
We can do filtering as well, but filtering is well under transformation or whatever, but the main thing is routing here. So yeah, so we have some metadata, we want to make a decision what should go where. So yeah, that's one key thing. And FluentBit is great because it interacts with the API server. It gets all the information, so we can make decisions here or later down the pipeline, because we also add this metadata to the log records. From now on, the logs are um, transported together with this additional metadata.
Okay.
The other problem is, okay, let's suppose we know the labels, we can understand, okay, we just want the developer workloads to be sent to Elasticsearch. Now we need a credential to Elasticsearch.
Credentials to Elasticsearch?
Yes, for example, credentials. So we have to manage this. So you put some credentials into a secret probably, and then you somehow want to pull that in to this configuration, to the FluentBit configuration, because FluentBit can't just pull in secrets from somewhere. So you have to put those secrets there. You might I don't know, want the developers to manage this or not, but we can talk about that later. But you need some credentials, and also in order for this to work, I will wait a little bit so that you can write. It's amazing. It's amazing that you can write and listen at the same time.
Thank you.
How did you learn that?
I don't know. Probably through this process a lot. So we're using FluentBit to manage credentials to Elasticsearch, and Elasticsearch is the destination for our logs in this case, right?
Yes.
Okay. To be consistent, I'll write to the destination.
And another thing or problem, or well, not necessarily a problem, but another thing to care about is that if FluentBit needs this information from the API server, then FluentBit needs Airbag to talk to the API server. And the problem here is that any logs can, so any pod can go here. So we need to access all the namespaces and all the pod information. So this will require a cluster-wide or a cluster role, which is a high privilege access in this case.
Cool. Mr. Rovaz, they use Splunk OTel Collector to collect Kubernetes events and pod container logs and forward them to Splunk. Is Splunk similar to Elasticsearch? It's I'm so clueless. It supports annotations on the namespaces and/or pods to route them to indexes and source types.
Yeah, that makes sense. So yeah, Splunk is a destination, and some of these destinations have their own collectors or agents, how they call them. Some of them already migrated to OpenTelemetry, like in this case, Splunk Hotel Collector did. We do the same, but our focus is on the collection part and on providing a multi-tenant interface for this. And regarding the destination, it can be anything. With at least with the logging operator, anything that FluentD supports, but that's we can talk about that a bit later.
Is logging operator meant for one cluster, or if you have a multi-cluster estate, is it helpful in that case too?
Not really. So if you have
Okay.
multiple clusters, you set up logging operator on each of these, and you forward to write to the destination. We had some ideas. We had some. I remember some use cases when we were forwarding from I don't know in a hierarchy. So multiple clusters forwarding to a single cluster, then doing some stuff there, and maybe forwarding to another destination, or just keeping the logs there. If, for example, if someone wants to set up their own destination somehow, then that could make sense, but not really. So no, typically single cluster, but multi-tenant.
Okay. Great. So this is coming into focus. Okay. So now we have the problem of credentials that need to be managed.
Yeah.
And so if it's FluentBit, whatever your daemon side technology is going to need cluster level access to be able to do this.
Yeah. And another issue is that you have to consider or be aware of buffering. So when the remote is slower than the producer, so if you can't send fast enough, or sorry, you can't send more because the destination is too slow, and buffers are filling up. What do you do with those buffers? How do you scale that? Because you might not want to lose logs. And the default behavior is with FluentBit, for example, is that if it can't send more, then it will drop incoming logs. You can say that, hey, please, FluentBit, don't do this. Stop your input instead. But then the problem is that, and it's called back pressure. If you stop the input, then the container runtime will still write logs to disk. So you will have all the logs there, but in case a pod is deleted, then you might lose those logs because you stopped reading it. So it will be gone. And these are the things that you have to consider, because you don't want to store too much data on the nodes themselves. You don't, because if you want to be reliable, then you want to read all the logs as soon as possible. Create a persistent buffer so that if FluentBit is restarted or crashed, or the node has crashed, whatever, you don't lose data because you keep track of the position in the file, and keep the data that you already read on disk, so that if you get interrupted somehow, then you can keep up. You know where you left off, and you know that here is the data that I still have to send to
somewhere. Yeah.
Yeah. So this is when you have to decide between performance and reliability, or at least have some balance. In this case, you don't want too much logs filling up on your nodes, and this is why FluentBit or a collector on the nodes itself might not be a good solution, or you might want to extend this architecture with something that can store or do other things with the logs.
Fuel Snobbles here. Hi, Fuel Snobble. We're talking about Kubernetes logs right now, but what do you do to manage logs, especially for different personas that need to access different logs? Cool. So, all right. So here's Do you have more that we should add to this? So
Yes, this is
uh-huh.
this is why we from the first time why we considered adding the aggregation layer, the aggregation or forwarding layer. We can depending on what is our focus. Uh, uh, we want to do, and this is how FluentD comes into the picture, because FluentBit is a very similar tool written in C, high performant, low memory consumption, uh, and low CPU usage. So low footprint in general. This is why it's a good fit for running on all the nodes. But FluentD had, at least back at the time, still I I'm not sure, because it is now not that actively maintained, but it had a lot more destinations. So it has a nice plugin mechanism that you can write your own destination adapter. So there are a lot of destinations in the wild, and this is how logging operator uses FluentD as well. So FluentD itself contains some basic destinations protocols, support for these destinations, but there are a lot of community developed destinations that you can pull in, add to the FluentD image. FluentD can understand it and use it, so that we could add support for all the different kinds of destinations user were asking for.
So
And
okay.
yeah,
Yeah.
that's one thing, but the main thing is that when we decouple the problem of collection and the problem of forwarding, then we
Mhm.
can use this daemon set where FluentBit
Um,
is the boss, and then FluentD operating separately, but not running on all nodes, because it's written in Ruby. It was initially, it was only able to use single CPU core. It consumes more memory, consumes more CPU. You might want to do more transformation, processing, regex expressions running, um, and you also want to be able to store more logs in case the destination is down. And the right way to do that is to use a stateful set, because with a
okay.
stateful set you can use a persistent volume, and on the persistent volume you can store your logs for a temporary time period.
Okay. So I'm trying to kind of like assimilate this extra information into the story, or like the the mental model I'm building. So so the one of the problems here, so this is how it works without logging operator. And one of the problems here is that we have the log collection and then the log routing in the same tool, and those two things can be decoupled. Is that correct? And the
Um,
just yeah.
Sorry, can you repeat the question? I lost track of it.
These five things are how it works, but really it's how it works without logging operator, how people are doing it without
Yes,
logging
so
operator, correct?
logging operator doesn't add magic here. It
Uh-huh.
just helps you by not having to figure this out on your own every time.
Uh-huh.
So you define a
Oh.
custom resource, and you say that I need FluentBit running, and
Uh-huh.
FluentBit and logging operator will do all this for you automatically, at least uh, with FluentD together, because you want to send it to destination. But it gets much simpler without having to understand all these different things to set up, because you would have to set this up on your own.
Okay. Okay. So so in terms of these bullet points, is there something else? I feel like I maybe missed by trying to understand, like, are there two things here that need to be decoupled? So is there anything else that that logging operator is solving?
Yes. So I try to talk the simplest case, because
Uh-huh.
in the simplest case there are still these problems that you have to figure out. It's
Uh-huh.
not that it's impossible without logging operator. It's just that you have to figure out on your own. Uh, the real value
Mm-hmm.
added on top of these is that you don't have any airbag, because you lost it when the container runtime had written out all the logs to your disk, and then the permission boundaries that are provided using Kubernetes airbag are all lost. So you either have access all the logs or none of the logs, and that's the biggest problem, even if you have all this. So we had an initial version of the logging operator that only solved these problems, and it was okay, because we could forward some of the logs to a remote destination, and it was nice. But then the problem was that, okay, but we would like to forward some logs to one destination, and probably some other to a different one, because there are multiple teams working in the same cluster. And then how to solve it, because who will manage this configuration? So there's always be an infrastructure guy, or the infra team, who will have to do all this, and oversee everything. And even if they do, how do you separate all these things in a clear way, that ideally also aligns with how Kubernetes works? And this is when the idea of the flows and outputs came into the picture.
So this is a lot to figure out, and logging operator helps you to manage all of this. Is my very simplistic way of summing up everything you just said. Do you think this captures it, and we can get into details about how logging operator does that?
No, I think we should talk about these flows and outputs. So the
Okay.
additional so the real value that adds logging operator, which is the, I don't know, was not the secret sauce, but the new thing that is leveraging Kubernetes, but helps you work with logs in a way that is much more convenient than writing the doing it the fluent way, because fluent bit and fluent D is nice, but the configuration of it can get really, really complex. I wanted to touch this. I don't want to get into the details, but it has a mechanism to tag every log message with a linear a string, actually, that you can match further down the line. So it's a sequential evaluation of rules that you can do based on what tag the log message has, and you can manipulate the tag and then do something with it, and then manipulate it again, and then so you end up wiring a crazy complex configuration, because and matching on labels is almost impossible this way. So
Yeah.
the secret sauce was the routing part in FluentD, when
Uh-huh.
and I almost forgot about it, where FluentD just sends all these things to FluentD, and FluentD had a feature that came out when we were trying to figure this out, which was a mapping uh, for you could attach an ID to your log, and you could
Mm-hmm.
define well, it was called a label, but don't
Yeah.
confuse this with Kubernetes labels. So it's a point in the configuration where you can redirect your logs depending on some depending on some condition, and this wasn't implemented. So the thing that Fluentd provided was this redirection. So you could tell that, hey, the logs from here go
Uh-huh.
to this ID, where the
Uh-huh.
configuration does something else. And the thing we added here was a plugin that could actually map a rule that you said that, hey, I want some pod labels to behave this way and another set of pod labels to behave a different way. And we could do this mapping, get the condition in a nice way, a Kubernetes native way, based on pod labels and namespaces, send and managed with a block of configuration that is independent of all the other mess that you might write in the code. So this was the real thing that otherwise without this routing part gets really complex in Fluentd. So that was the primary thing, and this is really connected deep into how the flow works, because the flow is
Uh-huh.
actually the abstraction on top of what I just described. So a condition, what kind of logs you want to do something, what you want to do with this, so some filtering, transformation, whatever, any additional things you want to parse it, you want, because it's JSON, you want additional parsing, and so on, and to be able to tell where these logs have to go. And
Okay.
this definition will be totally independent of any other definitions. So if you have two different teams that want to work on different names, that works in different namespaces, then they can have they can set up their rules, or the admin people can set up the rules, but
Uh-huh.
these will never collide with each other, and you don't have to care about the actual Fluent bit configuration structure.
Cool. So what I'm hearing is a flow like a custom resource. Uh, uh,
Yes, absolutely.
okay. So a flow is a custom resource, is a logging operator.
I'm sharing a diagram in a moment.
Okay, and we can play. Thank you for your request for a diagram. Also, I kind of wanted to address. Oh, good, you were able to share a link. Perfect. Let me put it up on the screen. So Fuel Snowball asks, why is everything called operators in Kubernetes? Do you want to have a yeah?
Oh well, that's another episode.
Yeah, right. That's
But
yeah.
I try to. So Kubernetes is mind-blowingly fault tolerant and robust, and,
Mm-hmm.
and the way it works is that it decouples the control from managing the state consistently. So Kubernetes in itself is a configuration management system that is consistent, and the way you add logic into to this system is that you add the controller that runs outside of it. So you
Mm-hmm.
don't write plugins or anything that runs inside the Kubernetes server process, but
Mm-hmm.
you provide the mechanism so that you can attach a controller, and you can define the API for these domain objects,
Mm-hmm.
and then the controller runs outside, and it's insane how well it is architected, because
Yeah.
inside the controllers, in the default case, if you use the client that is shipped with Kubernetes, client Go, um, it contains a mechanism to restore the whole state in memory that the API server has, but with filtering down just the resources, and you can also use labels or the namespace boundaries. But the way it works, that it always maps the latest information right to your controller in memory, so you interact with the state like it's local. You have to deal with eventual consistency, because typically you are not getting the information from the API server directly, but you interact with the local cache. And uh, and the way it works is that based on these state, you make a decision. You might want to make changes, then you interact with the API server as a controller or an operator in general. um, and then any change is made, you get the latest information again through that direct channel that gets you all that information. So it's extremely fault tolerant, because even if the API server dies or your controller dies, it can recover and it can follow up where it left off. Sorry, I can talk about this the whole day.
So, my 2 cents, my very quick way of explaining it is Kubernetes is a way you define your desired states, and controllers exist to make your desired states equal to the actual state. And in general, controllers are performing the logic. But when you introduce an operator, that means you need a controller with logic that's specific to your actual workload that's running on the cluster. And that's why an operator is different than just a regular controller.
Yeah, controller is a more, I don't know, which
Generic.
one is a more generic term, but
Yeah.
in terms of what we call an operator, it can have multiple controllers running
Uh-huh.
inside,
Yes.
which
Mm-hmm.
the
And it
logging
can manage.
operator has as well. So
Yes.
multiple controllers. A
Yep.
controller is concerned with managing one API object. But
Yep.
if you have an operator, you might have multiple different API resources
Mm-hmm.
that is
You might.
part of a bigger domain, but
Yep.
each controller manages a single resource
You might
typically.
have state dependent logic. Yeah. So yeah, an operator is a souped up controller. Cool. So we're talking about flows and outputs. Flow is what makes logging operator great. And it sounds like different teams will define different flows so that they get just the logs that they want to see. Is that correct?
Yes, that's one way how it can work. Yes, and and the
Uh-huh.
and the flow is typically namespace bound. Not typically, it's always namespace bound. So if you create a flow, then you have to create it in a namespace, because it's a namespace resource.
Mm-hmm.
And logging operator automatically attaches this information that it is created in a namespace. It will automatically add a rule, a routing rule, so that only logs that were originated from workloads of this namespace will be routed to your flow. So nothing else.
Okay.
And in order to provide a mechanism to manage multiple namespaces, because, for example, you are an administrator that wants to manage multiple namespaces or all namespaces logs with a single flow, then you can have a so-called cluster flow. We also have that. That is
Okay.
concerned. The naming is not well. It has the option to define multiple namespaces. This is why. So it's more a multi namespace flow actually rather than a cluster flow. But the point here is that these are separate resources. So you can give access to your developer team, for example, in their own namespace to create and manage a flow. And with that, they will always be able only to manage the logs of their specific namespaces. And if you want to manage more than one namespace, then you want to use a cluster flow for that. But
Is
that's
the flow meant to be developer facing?
yeah,
Okay.
absolutely. It doesn't have any restrictions. So if you need the flow as an administrator, why not? But it's a way to give more autonomy to your developer teams.
And it abstracts away a lot of this complexity.
The routing part, the transformation part with filtering included, and what is not covered with this is the output. So that is the other resource that we have, the output, which is concerned about forwarding to a destination and all the details about how, I mean, all the destination specific requirements that you might have to or want to fulfill.
Of collecting, routing, transforming.
Well, the collection, not the collection part. The collection part was still is still managed by FluentBit. So it's the flow itself at the moment. The flow itself is only implemented in FluentD in the aggregation layer. So the collection part is what FluentBit does. It's really, at least it was for a long time, a really dumb solution, at least how we implemented it, because we wanted to make put the focus on this routing part. So what we needed was an efficient and reliable way to collect all the logs, get them on the same place, where we can store them, where we can buffer them, and where we can make decisions, routing decisions efficiently. This is why flows are implemented in FluentD in the aggregation layer, which is going to change with the telemetry controller, but I hope we will have time to address that as well.
It's more about space than about time.
Oh no.
Declarative and reusable.
Yeah.
Cluster flow. To do this at the cluster level. Okay, let me make sure I have this right, and then there's nothing you want to add. So a flow is a custom resource that's namespace bound that a persona or team can use to manage the logs that they care about. It's meant to be developer facing, and it abstracts away the complexity of routing, transforming, filtering, and isolating logs.
Yeah.
That sound good?
Yes.
Awesome. All right. So then we have, and so FluentBit still takes care of collection. I'll capture that. And so now we still have the problem of getting the destination, making sure the logs are the format that the destination wants to receive. Is that correct? And then also this bit about buffers, but like, bit. Still does the collection. Okay, so now, so that's, let's put this blue. That's here. And now we have the output. What is an output?
Yeah, an output, that's boring, fortunately. I mean, the only thing that, well, so there are outputs and cluster outputs in this case as well. So outputs can be used or can be defined by the developer team, or so these are namespace resources. You can use define an output. The good thing is that you don't have to put the actual credentials into that output. You can refer to a Kubernetes secret. And then you can connect your flow with an output. So that's the deal here.
It's used to connect a flow to a destination.
Yeah.
Okay. Cool. And that's where the credentials are provided.
Yes.
And like protocols defined and that sort of thing. Cool. Excellent. All right. So we have, if we do this manually, we have these things to do, but with logging operator, we're provided with these two custom resources, and they can be used to abstract away a lot of this complexity.
Yeah, and unfortunately, one problem still remains that even if we separated these or isolated these flows, and we gave authority to these different teams. The problem is that it is still merged into the same aggregation, so in the same fluentd, the same aggregator, and it can cause problems if one team makes a configuration that compiles, I mean, syntactically correct, but has performance issues, or it looked correct but can't reach the destination. It stops the whole fluentd, and so even if it worked well when these teams were well behaving, it doesn't work well in situations where so you can't really give more autonomy to less I don't know less well behaving for example, if you want to provide a multi-tenant system and you have different teams who are between teams and customers, because you are a platform team, you build a solution. This is the typical example that we are now trying to address, or typical use cases, a more complex one, where there is a platform team. They are concerned of providing the right tools, the right versions, patching those software components that they providing the Kubernetes APIs for their teams. And logging operator turned out to be perfect for this type of problem. But if you just give them a flow and everyone starts to make their magic, then it will cause problems sooner or later. And we initially put more focus on making a logging operator smarter by by being able to scale fluentd, scale it up and scale it down. Well, that's another problem that logging operator solves, scaling down an aggregator that contains data. So when you want to scale down fluentd, it might have a lot of buffers on disk, and it won't flush all the buffers and send it to a destination. It will stop. You scale down your stateful set, and what do you do with all the data that is left on the disk?
Ah.
So that's another problem that the logging operator solves under the hood for fluentd.
Um, do you think I should maybe make a list of all these other problems logging operator solves list? Yeah.
Uh, Probably, yeah. So yeah,
Okay.
it's probably part of the management. So it's the part of that list where we expanded what management is in the first column. So
Okay.
collecting, routing, transformation, and scaling. That's I would only add scaling to this.
Okay. 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 So you've mentioned two so far. One was the scaling down.
Sorry.
Scaling down without losing logs, right?
Yeah, without losing your persistent buffers. That's yeah. Without
And then
losing.
what you gave one before that.
Sorry.
You gave one before that, I believe, about misbehaving teams and.
Yeah, we can call it the noisy neighbor problem.
Nice.
We typically call it that way.
Scaling down without losing logs.
Yeah.
And then the noisy neighbor, like, how is that solved exactly?
Yeah, we had an attempt where we the noisy neighbor problem came when the client the different tenants were well behaving, but they still required a lot of CPU for their environment to process and transform their logs. So one attempt here was to introduce a different aggregator. That was the point where syslog-ng came into the picture. We have strong connections here in Hungary with another startup. It was called Balabit, also acquired by a larger enterprise, where syslog-ng was born, and we knew them. We reached out and implemented a very similar API flows and outputs for syslog-ng as well, so we could replace fluentd and provide a more performance solution to this problem. But the problem still remained that if the tenants are not well behaving, the right word doesn't come to my mind, but yeah, so you can't trust your tenants, then you need some stronger isolation. So this is a scale we typically call soft multi-tenancy and hard multi-tenancy. The hardest the soft multi-tenancy is what we have with all these Kubernetes logs written out all to disk. We don't have any multi-tenancy almost at all. The hardest when you put different workloads into different clusters, then they can't interfere with each other at all. So you need a different logging operator in these different clusters, and that's all. You might even don't need a logging operator if you just send to Splunk with the Splunk collector. That's an option as well. But there's a middle ground because you might not want to manage a lot of clusters. You might not have the tools or the support. There are companies who provide this, but this is a feature that might cost a lot. So there are a lot of things to consider here. but there's an option to have a single collection, still have a single collection layer with fluent bit, but have multiple different aggregators isolated for the different tenants. And that was another evolutionary step, if I can call it that way.
Cool. Yeah.
When we had to introduce some kind of routing into fluent bit as well.
Okay. So the other problems that logging operator solves: scaling down without losing logs, the noisy neighbor problem, so one tenant can't use too many resources. And then it seems like you're about to say a third one.
Yes, when there are untrusted tenants, so not trusted, but you need to provide more isolation. That's not just about performance problems. It's about availability problems, or even we can be concerned about whether there is any I don't know, vulnerability that allows one tenant to access the logs of another tenant, because all the logs are now managed by the same aggregator. So you might want to have stronger isolation for a lot of different reasons. And we worked with companies that still wanted to manage less clusters, but have multiple different teams or multiple different customers on these clusters.
Mm-hmm.
And the collection part is still the same. So you still have to tail all the logs. That doesn't change. You still need FluentBit to process them. But when FluentBit sends it to somewhere, then that aggregation or aggregator should be isolated, should be fully separately managed. And also, one aggregator might need much more capacity, much more CPU power, the other might not, and so on. So there's a lot of reasons why you want to do this.
So it's not just about accessing each other's logs, but maybe giving different amounts of resources to different.
Yeah. Multiple reasons to provide stronger or harder isolation.
Mm-hmm. Okay.
Sorry, not heavy isolation, but we it's either stronger or it's, if we talk about isolation, then I would say stronger. If we talk about multi-tenancy, I would say harder.
Okay. Nice. I'm learning. Or to give, I'm just going to say, or other reasons. Cool.
Well, yeah, so tenants cannot access another's logs. That should already be true because the flow guarantees that. But accidentally, so I would say accidentally, or by using some vulnerability. So it has. I would a little bit rephrase that. Stronger isolation for. Maybe we can make it simple by stating for security reasons, and well, most of that is covered by that, because for example, if one tenant breaks FluentD because they provided a configuration that is syntactically correct, but doesn't work, and FluentD crashes because of it, then FluentD stops, and all the other tenants' logs will be stopped as well, and that's a security concern. So availability is a security concern again. What should FluentBit do when the aggregator is down? If the aggregator is down, FluentBit will have to buffer logs on disk, and then you risk the health of the nodes. So you can't afford that. So security is a very important reason in this case.
Cool. Are there more problems that logging operator solves that we should capture here, or do you want to try to get use the last bit of space to talk about the telemetry collector?
Let me see my list. Yeah.
Okay.
Yeah, there are some extensions because those are important as well.
Okay.
So some other use cases, like first one, host logs, logs that are not emitted by the container runtime, not coming from the pods, but
From the host
nodes
machine.
that are assisting Kubernetes or the hosts.
So I'm confused because is this list of logging operator extensions or logging operator use cases? Extensions?
We call them extensions. These
Okay.
are additional controllers. For
Okay.
example, the host tailor controller.
When you say controller, is that the same thing as a custom resource?
Yes, we have a host tailor custom resource. Yes.
Okay.
In this case, yes. I will talk about another one. That's the sidecar. It's a webhook actually. It's a different type of extension. So this is why these are called extensions, because some of these are controllers and some of these are webhooks, for example.
Ah, okay, I see. Okay, so are they custom resources regardless?
Not all of them.
No, okay. So we'll just call them extensions that just add additional functionality.
Yeah.
Okay, and then we have the host logs.
Yes, just enumerating these. I don't want to get into the details, but these are important because we want to keep these functionalities in the future as well. So host logs.
I like host machine logs because host sounds like a verb otherwise. Host machine, host. Cool.
The other is the event tailor. So Kubernetes has this event API. Controllers can send important. These are logs as well, but with attached metadata and with some. With also additional recording the frequency with which these events happen. So this is an API that is used when you describe a pod or describe a stateful set of deployment. You can see what is happening with that deployment. Kubelet is pulling images and so on. So the information that is happening, and this is managed through the event API in Kubernetes. And the events that are recorded in this API need to be polled or need to be watched for. And we had a component that did this, and we could also forward this with the logging operator. And the third one is the sidecar controller, not controller, sorry, the sidecar webhook, which works by looking at an annotation that you can attach to the pods. And based on that annotation, you can say that, hey, this pod has a container that is writing some logs to some files rather than to disk. So this is another use case that emerged, where there are some, I don't know, there are multiple containers running in the same pod, and even the same container writing multiple different logs. Like I think Tomcat did that, or maybe others, some legacy apps. So you have to, I don't know, legacy use cases, and then you have to figure out a way. Okay, but how can I get these logs out from the container, because it won't be written out by the container runtime. Uh,
Mm-hmm.
so this way you can just add an annotation, and when you
Mm-hmm.
create code with that annotation, this webhook that is implemented in the logging operator catches this and injects a sidecar, mutates this pod, and injects another container running besides your containers. Uh, that mounts that specific folder where your logs are written into, also modifies your original container to mount the same empty dir, and then they can interact through this empty dir, so that everything that is written to that file will be read and processed by the logging operator as well.
Cool. Epic Tralala is here. Hi, Epic Tralala. They said they were just about to ask about events, Kubernetes events, when you brought it up. I'm so glad you're here, friends. Okay, so sidecar webhook mounts a sidecar to capture additional logs. You're looking through your notes to make sure you got everything?
So far, so good. Sorry, let me check. I wanted to also talk about these extensions, and then really how we reiterated with this, because I wanted to tell that we had to. So a lot of times people came to us and asked why they can't extend Fluentbit more and more, and we pushed back that we don't want to add complexity there, just as much as we have to. We want to manage complexity on the aggregator side, but with this requirement, this isolation requirement, we needed a way to make Fluentbit smarter, and the way we did was, and this happened end of last year probably, was to add the ability to route based on namespaces. So Fluentbit can now use the information where a tenant, what namespaces belongs to a specific tenant, and route only those logs to that aggregator. So every tenant can set up their own aggregation using the same resources. So they can do almost like they can act almost like they are the administrators. So they can't just create flows, but they can create. We have the logging resource that defines FluentD and Fluentbit. Well, we introduced a new resource, the FluentD config and the syslog-ng config, so that you can define your own aggregator, but that aggregator will only receive the logs that you are concerned with, and will never send other tenants' logs to you. In order to make this work, there was one problem that we had to solve. Was the back pressure problem, because what if there's still this problem? What if one tenant goes down? So an aggregator that serves a tenant goes down, then FluentBit can't send logs to this tenant anymore. What should FluentBit do? Buffer logs or stop the input? It can't really do both or any of this when it reads the same input, because then if he buffers, then the whole node will be in trouble. If he stops the input, then all the other tenants stop receiving logs the same time. So what we had to do, and was a bit tricky with FluentBit's linear config, was to separate inputs. The input is that tails the actual logs from the file system, to separate inputs based on tenants. So now we have a separate input for all the different tenants that has a regex for reading just those, or a list that defines which files to read, because fortunately the file names contains the namespace, so we can use this to define, okay, here is a tenant, the tenant is concerned, or the tenant can only manage logs in these namespaces. Then we have a separate input for this, and if one tenant stops or goes down, then only the input for this tenant will stop, and all the other tenants will be unaffected. And we can decide if, so for example, there's still the balance of buffering logs or stopping the input. You might not want to lose logs either in this case, but you can, for example, set up an alert that notifies you that the disk is under pressure. You can understand that one tenant is down, and you can make a decision whether you want to stop the whole system, which you might not want to do, or lose logs for this tenant, or risk losing logs for this tenant. But that's up to the administrator at that point. So the point is that isolation doesn't isolation will protect the tenants all the way down.
Okay. So a locking operator separates inputs for the different tenants, so the different tenants can each solve the back pressure problem in whatever way they choose.
Yes.
Okay. However they want, which is availability versus reliability, right? Epic Tralala has a comment. I think I will update the logging operator tomorrow. Cool new features. They're currently running a 3.8 version. And I want, oh, yeah.
No, just to comment on that the API was or is backwards compatible. So we try to be backwards compatible as much as we could. So of course the price for that is that we have some obsolete fields and deprecated fields, and some custom resources we don't really use or develop anymore. But it should be easy to upgrade from that version, for example, as well.
I have a question that might be a very silly question, but you started using this word aggregator when an aggregator goes down. Is an aggregator like one process in a daemon set?
The aggregator is FluentD, a separate a stateful set, actually.
Okay. Okay, FluentD is the aggregator. I'll learn more about that tomorrow. Yes. Cool. Excellent. Well, I know you wanted to talk about this telemetry.
I would love to.
Yeah. Do you want to close out with that? And then I'll do a recap?
Yeah, you have to clear the.
You get this much space.
Okay,
I mean, talk as much as you want.
smaller,
We'll come up with a good
smaller
sentence.
letters.
I'll get my fine-tipped marker.
Okay, I try. So yeah, maybe we don't have to. If we can figure if we want to have another session for that. But I try to summarize and we will see. So
So this is an upcoming feature. It doesn't exist yet, right?
it exists already.
Okay.
It exists. It's publicly available, and the integration is not it's there. It's in the code. We wanted to. We are in the process of writing a blog post about that. On how to integrate the new stuff with the existing logging operator, but there's a shift that is important in this, that with making Fluentbit smarter and so with this need, uh, we saw that the capability and the flexibility on the edge, on the collector level, is important. And there are use cases where you don't want an aggregator at all. So there are use cases where when you are not concerned with losing logs or storing some logs, buffering a little bit on the disk. You just want to create a POC, or you're just a development environment, and you just want logs from A to B, but you are still concerned with the multi-tenancy bits. So you want some logs sent here, some there, and be able to provide more autonomy to the different tenants. And we were thinking about this for a while, and we also wanted to well. Fluentbit is nice, but with this tag-based routing, it's very complex to use. Fluentd has this label, that ID that we could leverage, but it uses a lot of resources. So either of these were ideal for this problem, and OpenTelemetry was coming up as the shiny new technology, and we started to experiment with it. Started to understand how the configuration look like, what are these pipelines, and it turned out that it maps to this problem pretty nicely. And when we first attempted to do this, the problem was that you couldn't route logs internally between these pipelines, and you couldn't build a hierarchy of things separating tenants and then these flows primarily that we were after. And it turned out we had a POC and proposed a solution that were rejected, but at the same time a solution was already underway to solve this, called the connectors in OpenTelemetry Collector, a new feature last year, and that was the missing piece. And after that, we could leverage that to build a very similar model into a single process, a single collector, a daemon set that is running all the nodes, but has the capability to route logs to build up this logical model on every node, with some caveats.
What's it called? What's the logging operators telemetry?
It's a telemetry controller that I added the link for in the beginning.
Yeah.
So we called it telemetry controller because we consider this as the missing piece for Kubernetes log collection. At least we would love to see this component as part of Kubernetes, or at least something like this. So it's a POC that we had in our mind. We implemented it, and we keep on pushing this towards production readiness, and to make it interoperable with the logging operator. And well, it's primarily producing OTLP output, OTLP destinations. So you can use it with whatever lock is accepting OTLP. I think Elasticsearch does, and everyone starts to provide OTLP endpoints. So it should be something that extends Kubernetes, adds the missing permission boundary with these tenants. So it even introduces this concept of tenants. So we now have a new custom resource called the tenant, which is the isolation boundary. Again, we don't require an aggregator, but we don't provide a way to add processing, transformation, and stuff that could break other tenants. So again, this is the whole thing is running in the same process. So what we don't want to do is let users break each other's tenant easily. But we want to make an efficient decision as soon in the pipeline as we can. So this you can still have the option to not use it, to route everything to an aggregator and make decisions there. But yeah, so you have to make this routing decision somewhere, and it's better if it's done as early as possible. So
what I came up with from that, this is my very simplistic fit in a small space, is your telemetry controller extends Kubernetes to manage OTLP telemetry data in a multi-tenant way.
Yeah.
Excellent.
Yes, something like that. Manage or collect and forward telemetry data in a multi-tenant way to OTLP endpoints.
Okay.
So not OTLP telemetry data, but telemetry data to OTLP endpoints. Yes. We also we plan to support a few key protocols. Like we support Loki for now, for the sake of the POC, so that people who use Loki can try it out. Loki now has an OTLP ingest endpoint in the latest version, so we might be able to just leverage OTLP there as well. But we also want to provide integration with the logging operator for existing users. There we have a Fluent forward exporter in the telemetry controller that can forward logs to a logging operator managed Fluentd aggregator as well.
This is great. So when you extend Kubernetes to manage, you said collect and forward. Would you prefer collect and forward over manage?
Yeah. Yes. Well, I'm also thinking about whether I want to add routing here, but in a multi-tenant way, that already somehow means that it's, yeah.
I like it. I like your consideration. So the way I like to close out the show, if you don't have anything left to share, there's no more room on the board, but if you feel like there's something you'd like to talk about, you're welcome to do that. And then the way I like to close,
just a little bit about the future. So now we are replacing Fluent Bits, the collector part, with Telemetry Controller, which is a bit separate from the logging operator, meaning that it's a different controller,
Ah.
different code base, leveraging some uh, um, tools, some libraries, but a different operator actually. And on the other hand, we at our current company at Exaflow, we are putting even more effort into our syslog-ng based aggregator code and log forwarder called exasyslog. It's
Mhm.
also an open source project, but so the point there is that the development of Fluentd has slowed down. Uh,
Mhm.
with the telemetry controller, everyone can send their data in a multi-tenant way to OpenTelemetry Controller.
Ah.
We don't want to mess with that. So if you have experience with OpenTelemetry controller, you can run it. We don't see that much value in adding, I don't know, tooling on top of for OpenTelemetry controller collector. Sorry, there is
Okay,
all
I was gonna ask, like, is this okay.
there is already an operator
Uh-huh.
which is maintained by the OpenTelemetry community. We are also watching them closely, interacting with them, talk with them on the latest KubeCon. Really nice folks doing it really well. So it doesn't make sense to extend it because now we solved the routing problem already on
Mhm.
the collector layer. We use the OpenTelemetry Collector in an opinionated way uh,
Okay.
in, in the telemetry controller. So it's not for the telemetry controller doesn't try to do whatever you want with OpenTelemetry Collector. It uses it to solve a specific problem, and
Mhm.
if you need to do more or you need other requirements, forward it. Let it be an OpenTelemetry collector or Fluentd if you are a Fluentd user, or our experience with exosyslog and syslog-ng puts us in a position where we can help the most with that. It's high performant and so on. So I don't want to emphasize that too much, but the point is that we put effort with the logging operator to be able to leverage that, and everyone can use their own favorite aggregator. Then they can decide if they want us to help. We can help with exosyslog the best, but they can self-serve with the OpenTelemetry collector if they want. So I think this is
So
a good way to.
in the future, the Open Telemetry Collector will replace Fluentd, but then you can still feed Fluentd through the
You
Open
can
Telemetry.
feed Fluentd, yes, but you can use just a plain collector because you don't have to write that complex configuration in it anymore, because with the telemetry controller, we already provide you the same way that you did with the logging operator previously. So a team that
Mhm.
has some boundaries called a tenant can define subscriptions. I haven't talked about this one, but a subscription is like a flow, but you can't define filtering and things like that. They're just subscribe to a stream of logs from a specific based on some labels, which are typically pod labels, but can be other labels as well. So the point there is that this routing problem is still available. So the solution for the routing problem is available, but you can later decide what you want to do where you aggregate these logs.
Awesome. Unlogging operator. Okay. Are you ready for a recap? Are you ready for me to repeat everything you said to me in a succinct way, in my child's mind way?
Yeah.
Cool. Here we go. And you're here to make sure I don't say anything wrong. But this is my takeaways, what I've learned from you today. So before logging operator, the problem we had was Kubernetes doesn't really have opinions about logs. kubectl logs isn't a reliable way to collect and forward logs. It's really for viewing logs only. Kubernetes delegates logs to the container runtime, and also logs from different teams all end up together. We're in standard out or written to a file. So logging operator is a multi-tenant log management solution for Kubernetes. And there's a star by log because it's soon to expand to include all telemetry data, not just logs, with the telemetry collector. And so then when we say management solution, what we're meaning is a lot of things. That's a very loaded term. So we're talking about collecting, routing, transforming, understanding destinations and protocols, isolating, and maybe filtering logs. All of those different things can fall under managing. So how does it work? So the 5 steps are things that logging operator is going to help you manage. And without logging operator, there are a lot of decisions and a lot of tedium to deal with, a lot of toil. So when you want to be collecting and using your logs, you want to send logs to a remote destination like Elasticsearch or Splunk. You need to install a daemon set to collect and forward your logs. So that you said probably FluentBit for that. You'll need to make routing decisions. So like which logs go where, which metadata is added, which metadata is used to choose which logs go where. How do you even enrich your logs with the metadata? All of those choices can get very complex, and you often just refer to the routing problem. Also, we have issues with managing credentials. You can use FluentBit to manage the credentials to the destination, but with multi-tenancy, that's difficult because FluentBit probably needs to access cluster level RBAC to be able to do that. Also, you need to be aware of buffers. So when the destination's slower at receiving logs than your cluster is at producing logs, that's called back pressure. And what do you want to do in that case? So what do you want to make sure you don't lose logs, or do you want to make sure you stay available? So you don't, and so that's a problem. And different teams that are sharing one Kubernetes cluster might want to solve this problem in different ways. So this is all a lot to figure out, and that's what logging operator's value is, that it helps you manage all that using custom resources. So we talked about flows and outputs as being the secret sauce. First of all, is there anything you want to correct or say based on what I've said so far? I think you might be muted.
Yeah,
No.
sorry.
Okay.
Yeah, the only one thing that I noticed, so where you talked about credentials and the airbag. So those are 2 different things. So
Okay.
needs airbag in order to talk to the API server, and this airbag is cluster-wide, a cluster level airbag.
Okay.
Yeah, and the credential stuff is that FluentBit needs the credentials for reaching the destinations. That's separate from this.
Yes.
That you have to give the credentials to FluentBit, and the way to do that is to put it into the FluentBit config. And if you want to somehow provide an interface for the users, then you can't provide them with raw configuration options for secrets. So you have to solve that, but that's a concern of the outputs that we touched later on.
Cool, great distinction. And Dorit, I see your question, and we'll get to it at the end of this recap, okay? So great distinction. So this is a lot to figure out, and logging operator is here to help us manage all of this. So flows and outputs are very important custom resources. A flow is a custom resource that's namespace bound, that a persona or a team can use to manage the logs that they care about. So it's meant to be developer facing, and it abstracts away a lot of this complexity, the complexity of routing, transforming, filtering, and isolating logs. So this is declarative and reusable. It's also, you could have a cluster flow if you want cluster level functionality. And here we still have FluentBit doing the collection. And then we also have this output resource that is managing how you could connect a flow to a specific destination. So that's going to have your connection details and protocol specific stuff, etc. So other problems that logging operator solves include scaling FluentD down, right, without losing logs. Is that correct?
Yes.
I'm going to write FluentD. Scaling FluentD down without losing logs. The noisy neighbor problem, so that one tenant doesn't use too many resources. Providing stronger isolation as needed for security reasons. Then there are also logging operator extensions. So there are logs collected. We're talking about container logs throughout this, but logging operator can also bring in host machine logs, Kubernetes event logs, and it can use a sidecar webhook to mount a sidecar to a pod to capture additional logs. I don't know if, inject a sidecar into a pod, I think is the right way to say that, right? To capture additional logs.
Yes.
Logging operator also separates inputs for the different tenants. So talking about this problem of back pressure. So different tenants can choose to different strategies for solving back pressure to either let something to balance availability versus reliability versus not losing requests, like being slow and making sure you have every request, or being fast and losing some requests. Injects. So logging operator helps make that multi-tenancy there. And then we gave just a little bit of thought to the telemetry controller, which is it extends Kubernetes to collect and forward telemetry data in a multi-tenant way to OTLP endpoints, for example, Loki. So you're saying as part of this telemetry controller, in the future, the OpenTelemetry Collector, which is different, it's an OpenTelemetry project operator, it can replace FluentD in this process, so that it's not opinionated in that. It can use FluentD as part of that OpenTelemetry Collector.
So the collector replaces FluentBit primarily.
FluentBit, okay.
Yeah, the collector. So it
All right. Excellent. Is there anything else you'd like to say or add?
And interacts or can interoperate with any aggregator, any OTLP capable aggregator, or FluentD, or XSS, which is actually an OTLP capable aggregator as well.
Okay, maybe I'll just erase this bit as opposed to trying to. But what I understand what you're saying. So the OpenTelemetry Collector itself doesn't replace FluentBit. Instead, OpenTelemetry Collector makes it so that any aggregator, OpenTelemetry compliant aggregator, can replace FluentBit in the system.
So almost the telemetry controller leverages the OpenTelemetry Collector to replace FluentBit, so that we can use FluentD or replace FluentD as well with another aggregator.
Excellent.
Yeah.
I'm going to remove it from the board, but I think it's great. Only because I don't have space to write it out, not because. But I'm glad we talked about it. All right, so we have one question here. what's the difference between logging operator, FluentD, and telemetry controller?
Yeah, so FluentD is a tool used by the logging operator to solve some of these management problems, namely the aggregation, routing, transformation, understanding a lot of different destinations. Yeah, these problems as an aggregator, or sometimes we call it a forwarder as well. So it's a piece of software that is part of the data plane, if we call this, because your data is actually flowing through FluentD. However, the logging operator is just to oversee, so it's a supervisor of FluentD, concerned about whether FluentD is running or not, whether the configuration of FluentD is what we want it to be, whether it has to be scaled up or scaled down, and if it has to be scaled down, what to do with logs. So logging operator is the supervisor of FluentD and FluentBit in the legacy scenario. And the telemetry controller is again a supervisor. It's again an operator, but with the notion of a controller, we try to emphasize that this is more closer to the Kubernetes core capabilities, or we think it should be at almost part of the Kubernetes capabilities to be able to manage your logs in a way that Kubernetes allows you to manage resources with isolation like namespaces and being able to filter based on labels. So these capabilities we want to fill with or fulfill with the telemetry controller, which actually a supervisor for the OpenTelemetry Collector, which is again part of the data plane. So all your logs and telemetry data flows through OpenTelemetry Collector, which is again managed by the telemetry controller.
Perfect. I think that's a wrap. Is there anything else you'd like to add? Or I'll briefly put up the website one more time, kublogging.dev. If you want to learn more or get involved. What if someone wants to get involved in the project? What should they do?
They should find all the information there. We have a CNCF Slack channel, so we are on the CNCF Slack. We have a Discord server. We are also available there if you prefer Discord. And yeah, we are posting under the exoflow.com website, which is our company website. So blog posts are typically produced there. We have other contributors as well, but we produce content there primarily that tries to help with different use cases or providing news and updates about the project.
Awesome. Thank you so much for sharing your time and expertise. I am going to dance my goodbyes. Thank you also. There it is. Watches the recording. I appreciate you. Bye. Thank you, Peter. Bye. Yeah.